requirements of the Nexys Instrument was to play the correct note on a on a keyboard. So any button on the keyboard that we have would play a different type of note, just like any other, like a regular keyboard. You know, each keyboard is meant to be as the IBM keyboard.
This is our simple block diagram. You have your general microblades, 2 LMBs and VRAM, and an OPB for all the stuff you need in EK. And then our inputs is mainly our keyboard and mainly a clock bit. We also have the keyboard which goes into UART Lite, which gets received into the OPB, which then spits it out to the SPI, which goes to the digital analog controller. And we take that analog signal with the PMOD amp so we can put it into speakers and get a sound. We also have an interrupt so we can control the frequency that we have on that way.
Okay, so the design overview. So the way it works, again, how Ryan said it was the keyboard to the Nexys to the SPI, the SPI to the DAC, DAC to the mod, and the mod to the speakers. So there was 2 steps to this. There was the keyboard part and the DAC part. The keyboard part, what we had to do is we had to first read the baud rate, which was a hassle at first because on the Nexys board the default setting is the 3.3 volts on for the jumper. So that's like we ended up burning our Nexys board the first time, just trying to look for it. Then we later found out like, oh, switch to 5 volts and it'll be fine. So I think a lot of people, I don't know if anyone else had that kind of problem. Then, so we had something called the UART read, and it's pretty much just 2 lines of code. One reads the status register. When valid data goes into the thing, grab the current key into there. And the way the keyboard works is it sends a code. Like let's say you hit A, it sends a hexadecimal code 1C. It goes 1C as long as you hold that. It keeps sending 1C. Let go of it and it sends F0, which means it stopped. And then it sends 1C again to say like, okay, this button stopped working or stopped being pressed. So one of the other issues we had to deal with was the fact that 1C was sent again. So we had to figure out a way to ignore that 1C signal after the zeros, so we just ended up using the flag. So then after we press the button, it goes to key and it goes through a list of different frequencies, which we looked up, and then we calculated the frequencies for each one. Looked up, it goes to the key, looks up which frequency, and then sends that frequency to the DAC set. And then the PMOD amplifies that signal into a speaker. Alright, so for the integration and testing, there's 3 blocks. There's the keyboard part, the DAC part, and then the integration between those 2. So for the testing, first we send this to the key to see if we can get on the LEDs, and then from there we would check if we can get just one single tone to read from the key to play one of the notes, and then the other half was to check the tones. And so we'd start playing. So we'd press the button to play different types of notes, and then finally put it all together. And then once we hit one of the keys, it play one of the notes. Any questions?
Alright, we're in that corner, so head on over. Being the theme from Beverly Hills Cop.
Nice. Yes.
It's easier if you say it while you play it. So QE, QQR, Q/QT, QQY, TR, QT, // And then this is a song from Coldplay, if you recognize it. So one where it goes, and then we have Oh Susanna. That one's a little harder to say because it's like 7, 8, 9. I don't want to do that. Equal signs and stuff.
Oh, and then we also added another feature so we could get even higher frequencies.
Oh yeah, so we have like 3 chords pretty much with all the sharps and stuff. And then if you press the button, you can go even higher. It goes 1 octave higher, which is pretty cool if we need any more notes. And this last song I learned in my piano class. Thank you.